Welcome back, dear members, to the final session of one-day seminar on global technology in practice. The final session will be emerging trends in blockchain and opportunities for CA. The session will be taken by Dr. Vinay Kumar Saini. A grand welcome to Dr. Vinay Kumar Saini, and it is my pleasure to introduce the speaker for the session.
Thank you. Thank you, Narayan, sir.
Yes, sir. Dr. Vinay Kumar Saini has more than 18 years of experience in software development, information security, training, research, and consultancy. He holds BTech in computer science and engineering and MTech in information technology and PhD in computer science and engineering in blockchain. He has qualified CISA exam and is Wipro and Infosys certified faculty as well. He has published many research papers in journals and proceedings of international and national conferences. He has delivered many guest lectures on various information technology, risk management, IT security, and IS auditing related concepts in leading institutions like CA Sri Lanka, IEI, ICAI, RDIAS, TIPS, and many more across India and abroad. So with this brief introduction, I once again give a hearty welcome to today's speaker, Dr. Vinay Kumar Saini.
Thank you, Narayan, sir. Thank you very much for the introduction. Thank you, Bangalore branch of SIRC. I think it's been an honor for me to be a part of this session where we are having a seminar on latest technologies and their impacts on practices for chartered accountants. It's always an honor to be on a panel where you might have experienced experts like Rafiq sir, Narasimhan sir, Anand sir, right? And it's really, I'm feeling privileged to be a part of this event, and welcome to all of you, and good evening to all of you. Well, you might have been exploring technologies like data analysis, then IT audit and AI/ML and IoT. So one thing is very clear, that technology is something which is inevitable. So for practicing chartered accountants or people who are into jobs, one thing is that technology is playing a critical and impactful role for any business organization. Having said that, we need to understand that our role on technological front is very specific, right? We are not here specifically like this chartered accountants are not here to develop technology. In fact, they are there to make sure that the technology is being applied, used, and implemented in the right manner, which addresses the needs of business objectives or business organizations. So the topic that I'm taking up for discussion is blockchain, and quite popular nowadays because of its growing application in various sectors, various domains, right? So before we start talking about this, I would like to quickly give you a basic introduction, an idea about what blockchain is, how it is relevant and useful. And then I'll quickly give you a small demo and then a demonstration quickly so that you feel the practical part, why blockchain is so special. And then I'll talk about what are the opportunities for chartered accountants and what are the recent trends, what are the different kind of applications which are being developed around this technology, and how chartered accountants can take up this opportunity for professional practice. So these would be my key areas of discussions. So let me just quickly share my screen. So here we go. I hope the screen is visible. Yeah, thank you. Thank you. So this is the agenda for discussion. And this would be a quick outline, like I'll be giving you introduction about blockchain, its applications, then impact on audit, risk challenges, some use cases, and a quick demo. Perhaps I'll take up demo before I explain all these things so that you get an understanding, right? How blockchain is so special. And then I'll talk about some use cases or some of the different kind of projects which are happening. People might be interested in concepts like DeFi, right? Distributed finance or decentralized finance kind of things which are coining up. Then concept of NFT is there. So there are so many things that are happening in this domain. So as a chartered accountant, I think it's really important to understand how these technologies can be considered to be a key component of your portfolio, right? So there are a lot of opportunities. So stay tuned and pull up your socks. Let's go for a ride for blockchain, right? So in basic terms, what blockchain is, if you start thinking about blockchain, the word says chain of blocks, right? So most of the time people, even if you study various articles and you go through various terms, you will see that it's more of very complicated. It's a series of complicated terms which explain blockchain, right? So, but let me tell you, the concept of blockchain is not that complicated. It's basically a technology which is there to solve a problem, right? So we must understand what problem it is solving and then how it is solving. If we get that clarity, I think then blockchain becomes a very easy concept, right? So let's take up this whole concept in a very simple terms. So of course it will be a chain of blocks, but why this chain of block is there, chain of blocks is there, and why we are having a chain, right? So we will quickly talk about that. Then there is another cartoon here. You can see that it gives us a different perspective, right? So if we start understanding, okay, what blockchain is, blockchain definitely gives you some solution, as I mentioned. But is it all about cryptocurrencies or financial transactions? Like there is no intermediator and we can have quick transfer of money between two parties. Is it the only thing that blockchain can do? But no, that's a basic, that's a big myth that people have, that cryptocurrencies is the only area where blockchain can blossom. But let me tell you, blockchain is just a technological concept which can have wide variety of applications. So here you can see there's a retail store, and so this person is replying to a customer that, sorry, you cannot pay for your coffee with Bitcoin, but you can join our loyalty program that is based on blockchain. So it means the concept, the idea behind this cartoon is simply to give a clarity that blockchain has a huge amount of applications outside the domain of cryptocurrencies, right? Now let's simplify this whole complicated thing. Why blockchain is there and why it is so special? What solution it brings? Like, I mean, what is so special about blockchain? So if you want to understand this in very simple words, I think it's time for us to go back to our memory lane when we were kids and we used to play football in the ground in nearby our locality. I hope you all might have experienced this, right? So what happens in a local, locality match, football match? There are two teams, right? And most of the time you will see that there'll be no referee, right? As we have in high profile matches like FIFA and other major tournaments, we'll see that there are two teams which are being created based on friend circle and all, and then there is no referee, right? But every individual player who is playing this game is a expert witness, perhaps the witness of the game, and everybody is involved in how the game progresses, right? For example, let's say if somebody commits a foul with a hand, everybody is observing, and then there is a claim, okay, it's a foul handball, so it needs to be addressed accordingly, like a free kick or whatever is there. So now you see everybody is watching the match while playing. It means that all are contributing in the activity, and everybody is having equal rights, equal visibility, equal capability in the game. So if there is a foul, if somebody claims that it's a handball and others are observing and they say, yeah, it's a handball, so means there's a consensus and they decide based on consensus whether it is a foul or not, right? And let's say if team A scores a goal to team B, then everybody understand that the score is 1-0 when we have A and B teams, right? So let's say by the end of the match, the score is 2-0, right? And everybody knows that the score is 2-0 because everybody has given consensus on how the game has progressed, right? So it's like that there's a network of nodes or people who are contributing to a system right? And everybody has the same visibility, same understanding of the system. So if somebody says that at the end of the game, the score was not 2-0, it was 2-2, it would be a false claim and everybody would reject this claim, right? So in fundamentally, blockchain is a system where there is transparency. Perhaps you can say it's in sync with the democracy. Let's say there are 100 people, so all 100 people would be part of the system where transactions are happening. And whatever transaction happens, however it happens, every member of this pool of 100 members can see that, right? And if everybody, if the transaction is happening in consensus with all the people, and if it is following all the rules, then it will be considered as successful transaction, right? So in simple words, blockchain is a distributed ledger, perhaps a network of machines who are working parallelly, and they are having same visibility of the system, and they are having direct connectivity with every single machine. So let's take a very simple example to make it more clear. That let's say in this meeting, if I see there are 77 participants, right? Let's say if somebody asks a question, right? Let's say somebody asks a question that, okay, what is blockchain? So the moment there's a question by somebody, everybody is busy having the visibility of the system. So everybody comes to know that somebody has asked a question, what is blockchain? So this is a simple transaction which everybody has seen. And if this transaction agrees to the rule of the system, this would be considered as a successful transaction. So if I answer the question that, let's say this question answer is basically a transaction in the system. So as there's a question, there will be an answer. So these are getting processed as per the rules. If say, let's say the session is of blockchain, if somebody asks a question, okay, can you tell me something about how, what is the chemical reaction works? So I would say, okay, this question is not pertinent to the session. It doesn't relates to the session or the topic. So it's an invalid question. So means blockchain is a system where there are certain rules and everybody is observing how the transactions are happening. If the transaction follows the rules and it is processed by one of the node, everybody gets a copy of a successful transaction. So they will keep on recording the transaction. So in a way, it's basically, blockchain is basically a collection of computers where all computers are having equal capability with equal rights, equal visibility, and the same copy of blockchain. The blockchain is nothing but records stored in a structured way where you have blocks, and a block can have more than one transaction. And there's a threshold, upper limit. Once you meet that threshold, a block is created, and after that, a next block is created. I'll give you a quick demo on how this technical thing happens so that you get a clarity. But for the moment, in simple terms, you must understand blockchain is basically a collection of machines who are having ability of storing, processing, validating, and keeping record of transactions, the same record on every single machine. So we are not having a risk of single point of failure. We are eliminating risk of tampering or manipulation of data once the transaction has been committed or verified successfully. And then we can have transparency because every machine has equal visibility, equal rights. And then we can define various other parameters like rules in the form of smart contracts. We can have various other factors like ownership, if you want to define ownership or not, right? Whether you want to keep it as a public blockchain or a private blockchain. So there are various factors, but let's have a basic understanding that it's a system where there are machines who are storing, processing, and verifying transactions, and equally everybody is having equal capabilities, right? Now, these are some of the features, characteristics of the blockchain, that if you have a blockchain based system, your data transactions will be secure. Once the transaction has been processed or executed, you cannot change and alter the data. Transparency means every machine on the network will have the same visibility, same copy of the blockchain, and it is distributed. So distributed means there is no single one machine or a server which is holding the data. Perhaps every machine on the network has the same copy or exact same copy of the data. And finally, privacy. Privacy means you can control and define on how much data should be visible to whom, right? For example, let's say if somebody is doing some transaction, so the data of that transaction should only be visible to that person or the person who is the other party involved in the transaction. Otherwise, nobody else should be able to see the data, right? And you can, because it is highly, secure system, and it uses cryptography end to end. So you can define the controls in a way that the data visibility would be absolutely zero, right? Beside the sender and the receiver, nobody else would be able to have any visibility of the data. All the data would be encrypted. So these are some of the features. Having said that, I must mention one thing here, that blockchain is basically a customizable technology. It's not that there is a standard product or a tool available. It's basically a technology which has to be customized based on your needs, your requirements. So it means that there's always a scope of how you want to design and develop the system, what kind of controls you want, what kind of operations you want, what kind of, business rules and conditions that you want to incorporate, you want in the system. All these things are customizable, right? So far, I hope you have understood that blockchain is a system which, facilitate transparency. You cannot change the transaction once the transaction is done. It is highly secure. It is distributed, so there is no single point of failure, and you can ensure data privacy. Now I will take you to a quick demo session where I will show you how this all things happen. Why I'm saying it is immutable, why I'm saying it is secure, right? A quick demo will give you more clarity. This demo will let you understand that what is happening behind the system, right? I am saying that blockchain is basically a collection of machines and they are doing all these things. What is happening within that machine that leads to security, immutability? Once you understand that, after that, we'll discuss about what are the professional opportunities for chartered accountants and how chartered accountants can play active role in various applications of blockchain and various other professional practices, right? So it's time for a quick demo so that you can relate to what these features are and how this is happening in the backend at the technological front. So let me just share my screen where I'll be showing you the demo, right? Just a second. So I hope this website is visible. It's a browser window, blockchain demo.
Yes,
right?
it's visible. It's visible.
Thank you. Thank you very much. So we must, before I start discussion about this demo, we must express our sincere thanks to this person, gentleman, Andres Braunworth. This is a person who has developed this platform where you can have quick demonstration about blockchain, right? So the person has taken some basic assumptions. Based on some basic assumptions, this blockchain, dashboard has been built where you can have quick practice of how blockchain work. So before I proceed, let me tell you one thing. There are three fundamental concepts behind blockchain. If you talk about technical aspects, let me quickly tell you about that before I give you the demo. Right, just a second. I just need to give you those three aspects before I actually give you the technical explanation about how blockchain works. So there are three important pillars for blockchain application, right? So these are, first is distributed ledger, right? Second is PKI, public key infrastructure. It is part of cryptography. And third is hashing, right? I'll quickly give you an idea about this. Okay, so these are the three pillars. Distributed ledger, I told you, it's basically collection of machines which are connected to each other directly, like means they have the capability of one-to-one, peer-to-peer communication. right? So distributed ledger means peer-to-peer connection of machines, peer-to-peer. It means these machines can talk to each other directly, right? So it's like they are machines connected over the internet and they can have direct communication between them, right? So distributed ledger basically ensures one thing, that is no single point of failure, right? Even if a machine is down, there are many other machines which are available for processing your transaction, verifying your transaction, right? So no single point of failure. Right. So PKI is public key infrastructure. I hope you might be aware of it. Idea is to assign unique addresses so that you can facilitate transaction, right? You all know that there's a requirement of identifying sender and user, right? So if you want to facilitate a transaction, you need to have identification of sender and receiver. How we'll have identification on blockchain based network where it's anonymous and it needs to be secure. So the concept which is used is PKI, public key infrastructure. There's a concept of private key and public key, right? Private key is your unique identifier. It's like your wallet address through which you can initiate transaction, right? And public key is again your address through which you can receive transaction, right? So you can say private key is for authentication and public key is for processing the transaction as a sender. Like if I want to send some amount in the form of Bitcoin to you, what I need is your public key, right? So I need receiver's public key so that I can transfer that amount to that person, right? So public key means maybe known to everyone because it's basically an account number to which you want to send your amount, okay? And private key is your authentication mechanism. So this is the key which is only private to you. You have the key and you can access your wallet and can do transactions with the help of this key. And you can see the transaction log and everything. So it's basically a very sensitive record, private key. And if you lose this, then you are in a serious risk, right? So you should make sure that you are keeping it safe with you. And the last one is the hashing. This is basically for immutability and data integrity. You can say data integrity in a simple way, right? So these are the three pillars. Distributed ledger means there are many machines. PKI is for identification, right? Who is the person, like digital identity, right? Public key, private key. If you want to send something to somebody, you need public key of that person, and private key is only available with you. And hashing is basically a technique where you are converting the data into a small summary so that you can verify whether somebody has altered with the data or not. So these are the three important pillars. If you have clarity about these, I think we are good to go with the demo part, right? So let me just take you to the demo part now. Yeah, here we go. So here we can see this is the first segment of this demo, and here it is written SHA-256 hash. It means we have a hashing function, hash function, which can convert data into summary. So let me say there's a data, say V sends rupees 1,000 to R. Okay. So let's say this is a transaction. So once this data is there, you can see it has been converted into summary. This is the summary. This is the hash code related to this data. Okay. If I remove this, so the hash is different. So means even the blank data has some hash, right? If you have computer available with you, like a laptop or system, you can open this URL, right? And you can try it also. You will get the same thing again, right? So the point is, you put any data. If I write hello here, you will get some hash, right? And you will see that because the same algorithm is being used at your machine also. So this capital HELLO will have the same hash code, right? Now, what is the purpose of this hash code? The idea is that for this data, let's say I have some data, say hello world. This hello world will always have this hash code A591 and with 46E. It means, let's say I have done this transaction, right? And after some time, if somebody comes to me and say that the transaction is not this, the transaction is like this, hello world one. So I would simply say, no, this is wrong. Your claim is wrong. Why? Because this hash is not matching with the original hash that I have. So it means that if I convert some transaction or some data into a hash and I store that hash with me, I can always verify and check whether anybody is trying to change the data or not. So it's like a proof of fact. So if I store this proof of fact, that is hash code, I can always verify and check, cross check whether somebody has changed the data or not. That's the concept of hash. And every time I'll put hello world, I will get the same hash, right? So that simply means that this hash is only associated with one piece of data. And whenever I present that piece of data, I'll always get the same hash, right? And it's not limited to the length of the data. Even if I have a huge amount of data, let's say millions and millions of transactions, even then I can convert that millions of transactions into a simple hash code. And this hashing concept can be used for data migration check also. Like if somebody is moving data from one machine to another machine, and let's say it's a huge amount of data, so you can convert this whole data into a hash code, and then post migration you can again convert the data into hash code, and you can match whether both hash matches or not. If they match, it means there is no tampering, no change, no alteration of the data. So this is a fundamental concept of hashing, and it is a pillar of blockchain. How it is a pillar of blockchain, I'll show you in the next segment. So from hash, we go to the block thing. So now how this hashing thing is used in making a concept of block in the blockchain. So if you see, this is a block has a serial number. Then there is a number, some number is there. Nonce, the full form of this word nonce is number only used once. So this number would be used only once. What is the significance? I will tell you. Then there is a data as we were having in the previous segment also. And then there is a hash code. Now there's a small change in this. If you see the previous segment, the hash was a random number here, right? Which is generated after this calculation, SHA. This is an algorithm, SHA-256. You pass any input, it converts it into hash code, right? So we can say that even a blank data has some hash code, and it's a E3B0 in the start. But if you go and check this block, you'll see a small interesting observation that the starting 4 digits are zeros, right? So that means that there has been some additional programming that has been done here, and we call it as difficulty level, right? So what is difficulty level? Let me just tell you. The difficulty level is one level of security added to blockchain systems, right? So difficulty level means that the hash should follow certain rules. Rules for acceptable hash. Here, the rule says the hash should start with 4 zeros. It means the difficulty level is 4. You can customize this. You can make it 6, 8, 10, 12. It all can be done by the programmer in the backend, right? So more the difficulty level, more it is tough for making change or hack or cracking the blockchain, right? So in this case, the difficulty level is 4, right? So let me just show you. It means that if say you are sending some data, say this is your transaction, say V sends money to say 1,000 rupees to say R. So let's say this is the transaction, right? So this is a transaction, and you can see the code is hash code is something which doesn't start with 40. It means the block would not be accepted. It would be marked as invalid, right? So if somebody is sending this block as a transaction, and you can see that the block doesn't start with 4 zeros in the hash, so it means it's not a valid acceptable data. So it means that you are supposed to solve this problem where you have to check for a valid number, like here it is written 72,608. You need to have some number which will basically give you an input wherein you must mix this number with the data, and the result should be a hash which has 40, acceptable hash, right? So it's just taking some time. It's basically trying to figure out a number which gets connected, just a second, which gets connected with the data, and it results in a hash which is acceptable hash. Okay. Wait a second. Let me just refresh this page, and we'll get the result. Wait a second. I think something is. Let me just refresh this page. Let me just load it again. Just a second. So I hope the idea is clear up to this mark, that when we are sending the data as a transaction, we have to maintain certain difficulty level. The idea behind difficulty level is to provide a first layer of security in the blockchain system. Say, let's say if somebody is making a false claim that this is my block of data, so it should be verified against various checks. There's a saying that multiple layers of security ensures the strength of the system. So instead of having one single layer of security, it's always advisable to have multiple layers of security. So and we call it as defense in depth principle also. So if you see, let's say if I'm writing hello here and I click on this mine button, it means it will check all various numbers and it will look for a number which gets combined with the data hello, gives you an acceptable hash. So if you can see here with the word hello, there's a number 32,904. This number would be used only once with this data and you get a acceptable hash after mining. Okay, so means mining is the process where you are looking for a number which is getting connected with the data and you get an acceptable hash. I told you can increase the difficulty of this algorithm by increasing the number of zeros that should be there in the starting of the hash code. So you can customize this based on your requirement. Like if you want to make it more complicated, more tougher for hackers to break the system, so you can increase the difficulty. So the block is basically a set of data, right? And the first level of verification is that the block should follow the rule of difficulty. It should only give acceptable hash, only then a block would be accepted, right? So you have to generate a number which gets added to the data, gives you the acceptable hash. So once you create acceptable hash, only then your block would be accepted, right? So it means that, let's say somebody wants to, let's say there's a blockchain, we have got some transactions going on, and let's say some data is there. Let's say these are the 3 blocks, and there has been some transactions, like you can see there is no data right now. But say, let's say somebody wants to make a change in the existing transaction, right? And let's say he posted this. So the first level of verification said that there's an alteration in the data. It is not acceptable hash. So it means you have to mine the block. So it means hacker has to mine the block first, and then he will send to the blockchain for verification that please accept my block and add it to your blockchain, right? But let me tell you one thing. If a hacker sends block like this, you need to understand that there is not only one machine, there are many more machines also. So they will reject the what do you say, claim of that particular sender, right? Now, one more thing is there, like if a hacker wants to make a change in the block, it's easier to make change in the last block rather than the first block, because if you change the first block, what will happen? All the other connected blocks will become invalid, because all these blocks are connected to each other through their hash code, previous hash code, right? So you can see then the hacker has to make changes or mine first block also, then second block also, and then third block, so on. All the blocks need to be mined. So it means that it's very difficult for a hacker to make a change back in the blockchain. It's perhaps easier if you want to make a change in the front, like the newest block which is there in the blockchain. You can make changes there because you only have to mine one block, right? So this is the concept. So idea is that these blocks are nothing but collection of data which are connected to each other by previous hash, right? So this way hacker has to make changes in the blocks before it has to send the transaction for approval. Now you go to the next segment, that is distributed. Here, if you see, you will see that the concept becomes even more complicated. Why? Because there is not only one machine. There are many machines as per our distributed ledger. So you can see peer A, peer B, peer C. So we can have n number of machines. More the number of machines, more secure the blockchain application is. So if a hacker makes changes here, let's say he makes some change here, so you can see this block becomes different in color. So it is an invalid block. But even if he mines this block and sends this as an acceptable block, it would not match with the other blockchains. So other machines will reject the claim of the hacker that somebody has made a change in the so whether the claim by a hacker is legitimate or not. So it would be rejected, right? So if you take a look at the next segment, you will be able to understand that this is how these blocks hold various different kind of transactions and data, and they are connected to each other. And the threshold can be defined like based on the required performance, like how much time you can afford for a transaction verification, right? So nowadays, many applications which are using blockchain, you might have observed that when you do some transaction, they say that there is a waiting time of this much for a transaction to get processed, right? So the idea behind that is that that's the time which is required for verification of the transactions and updation in all the blocks, right? So it's basically a mutual consensus between various machines in the network. That's why I told you, the more the number of machines, more secure it is. But then it has a trade-off also. If you have more number of machines, the verification time will be more, or perhaps it will take more time in updation of all the machines. Once the data gets updated in all the machines, only then complete successful execution of transaction is acknowledged. So that's the concept behind the blockchain, that the data is converted into hash, and the hash code is used to connect various blocks. And again, I told you it's customizable. So it again depends on the design and the requirement, whether you want to store the data in the blockchain or not. If you only want to store the hash of the data, even then that is possible, right? And you can have a hybrid approach that you want to store data separately and you want to store hash in the blockchain, right? So it totally depends on what are the business objectives, and you can add more and more level of verifications and more rule base to verify the transaction, right? Means like you can define a concept like Coinbase or a basic what do you say rule book, which will give you the idea about the amount every person is holding. Like if let's say you want to transfer some money to somebody, you can only transfer if you have that much amount of money, right? You cannot send if you don't have the money. So you can add that kind of a rule book there, or a list that these are the account balances of these people. So if they want to send money, so first it would be verified from the account balance book, and then difficulty level, and then of course the approval of all the machines, whether the record has been verified and updated in all the machines or not. So that way you are basically creating a democracy, a huge big network of machines which are observing and following everyone, right? And if one machine is down, you don't have to worry. All other machines are there. They are working as a team parallelly, and everybody's consensus is important. At least majority, that is 51%, people should agree that this is a successful transaction. Only then it would be added to the blockchain, right? So this is how you can understand how blockchain ensure a robust structure to hold the data, right? So now let's go back to the PPT presentation. I'll tell you now why blockchain was introduced, right? So now you can see the existing system that we have is driven by databases, and it's a centralized system. In centralized system, what happens is that we have a database where all the machines and there's a server where you have the database, and all users are connected to that central authority. And whenever you want to do some transaction or operation, that gets updated in the database. But you know that the ownership of the database is with some individuals, and they have complete authority, complete rights on the data. They can control who should access the data, and in fact they have the ability to alter and change the data as well, right? So this is a serious risk. Whereas when we talk about blockchain, there is no one who has a central authority. All the people, all the network, all the machines which are there in the network have equal capabilities. So you cannot have ability to change the data, right? You can only work as per the rules. Like if you have the authority of initiating a transaction, you can only initiate a transaction. And once the transaction is processed and committed, you cannot really roll back the transaction, or you cannot alter the transaction also. For example, let's say I send 1,000 rupees by mistake to somebody, and the transaction is verified. I cannot roll back. I cannot get back those 1,000 rupees. Only the way out is the sender has to initiate another transaction by which he is sending me 1,000 back. So this is the concept with the blockchain. And when it comes to integrity, there is absolute assurance in terms of hashing, that once the transaction is processed and verified, you cannot alter the data, right? And if somebody wants to make a change in the data, it would be rejected, because there's a consensus between the machines. At least 51% majority should agree that if there is any change, this is a acceptable change or a very valid change. Otherwise, they will reject the change that you are posting in the blockchain. So it is impossible to make change in the data in a blockchain based system, right? So this is a very important characteristic of blockchain, which can be used to build system where we can have fraud prevention because of tampering of data or change in the data post transaction, right? So we can eliminate that risk. Then when we say that, when we talk about the transparency, when it comes to blockchain, everybody has the equal capability, equal authority and visibility of the system. Whereas in database driven systems, it's basically the authority of the owners in the database of the system. Centralized authority is there. They control what is visible, what is hidden, and what should be shared with the users. So there's a basically restricted functionality is available, and you don't have complete transparency about what is happening behind the system. Whereas blockchain gives you complete transparency. When it comes to cost, if you talk about a centralized system, setting up complex servers and backup and other things are definitely costly. And if you are talking about some transactions or operations where multiple agencies are involved in the operation, then it becomes very costly to design a system and integration of the systems which are handling multiple parties. Whereas if we have a blockchain based system where multiple parties are involving and they're contributing to the transaction operation, you can have a very cost effective system, and you can have cost cutting, and you can cut down the cost substantially, right? I'll give you some examples and use cases so that you understand what it means when it comes to total cost of ownership, right? How much cost it takes to own a blockchain based application. Then when it comes to speed, blockchains are a little slow as compared to database, because database are structured data and they have some standard technologies like SQL and all, which doesn't take much time in processing. Whereas blockchain transaction verification and updation in all machine, this takes a lot of time, right? And finally, the trust. Basically, blockchain is suitable when you are building a system where you want to have trust incorporated in the technology rather than trusting the people, right? So blockchain is suitable when you have a transaction where users may not be knowing each other directly, right? Or maybe they just want to do the transaction and means the people who are not trusting each other but still want to do business and want to operate, so they can have blockchain based system which are having trust in itself. So blockchain incorporates the trust within the technology. So you don't have to rely on trust on the people. So idea behind blockchain systems is to eliminate human involvement in the operations. So when you look at the design of blockchain based application, you will see that human factor is minimal. Only sender and receiver, two direct parties are interacting. Otherwise, nobody would be the middleman. Nobody would be there in the uh, uh, in between these two primary parties. All the operations which are there within this whole operation would be done automatically by the technology. So that's the concept, that the trust is built within the technology, and you don't need a scenario to where you need to have a trust between the people. So it is suitable for organization or businesses where there's no need of trust requirement between the parties, and suited for organizations where there's a mutual trust. So let's say you have vendors, suppliers, and there's a trusted people, that you have a panel. Then I think this database driven applications are more suitable because you have very limited and clear cut requirements. So you may have a faster system based on databases. Now, with this thing, you must have a question in your mind. What are the scenarios where you must have blockchain-based systems? And what are the scenarios where database-driven systems are more suitable? Now, here I want to make sure I want to clear one thing to all of you. It's not that blockchain should be used everywhere, right? We as auditor, we as what do you say, experts, must understand that what is the requirement of our business, right? And accordingly, we should see whether blockchain is a suitable option or not. It's not that blockchain is, of course, blockchain provides security, it provides immutability, but that doesn't mean that you will apply blockchain everywhere, right? Here comes the role of chartered accountants, right? We need to make sure that blockchain should be a valid business, blockchain should be a valid business case. Otherwise, it's basically a wastage of money, right? I'll give you more clarity about it. Just a second. First of all, let's understand what it means when we have a system based on blockchain and what it means when we don't have a blockchain based system. So here are the scenarios before blockchain and after blockchain. Well, before blockchain scenario is where you have some sensitive data, personal data, financial data, and identity data, right? And you're doing some transactions, like you have various wallets, credit cards, and all other online platforms are there, websites are there where you're doing online shopping, right? Now what happens? You basically log into your account and then you do transactions, your credentials are there, everything is there. Now there are players, vendors, platforms are there, banking websites, and then you share this data with them. And then what happens is, many a time these banks further share your data with somebody, third party service providers or vendors, that may lead to data privacy breach or stealing data, or various other firms may sell your sensitive personal data to other companies as well. So there's a serious risk of violation of data privacy, right? So this is the system which is there. in practice. So there is always a high risk of data privacy breach, and your sensitive personal identification data is at stake, right? Now, what happens after blockchain? So you have this data and everything. So you will connect to a blockchain network where there will be an application, right? And you will not have or you will not share directly your any sensitive personal details. It will be basically your what do you say, private key through which you will log in, and then after that, whatever transaction operation you are doing, you can do that. And once the operation is done, you will get the confirmation, right? And the thing is, you will have a control on what data you want to share, to whom and which party you want to share the data, and all those things can be controlled when you have a blockchain based system, right? So basically blockchain leads to more control around your personal data. And in fact, you can have anonymous access as well, right? So if you want to just hide your digital identity, or means your personal identity, that is also possible with blockchain. So it totally depends on what are your requirements of the application, and accordingly blockchain based system or application can be designed, right? There is no single point of failure. If this servers or database get hacked, you lose your data. But here there is no single point of failure. There are different machines and all have the same copy. Even one machine is down, still your operations would be keep happening, right? So you don't have to worry about the security and availability. So you have enough machines which are available to provide you services. And you can define and control how your data should be used and shared across blockchain application. So you have much more control and authority on the data. Now, when we talk about blockchain applications, so India is really quite progressive and quite active nowadays in adoption of blockchain-based applications. And let me tell you, these are the various states where blockchain-based applications are in development. There are most popular use case is property registration, land property registration, because this is the area, land registry, where because this is a public service area where there are a lot of frauds, like the properties are sold to more than one person, the same property. So there can be a lot of frauds around such services. So I think this is an excellent technology which can eliminate such kind of frauds, right? And the other things can be like education is another important area where you have tampering of certificates, degrees and all, right? And the same way you can have it for digital identity also, right? And intellectual property rights, like if you want to have ownership of some digital data or digital content, you can put it on blockchain. And when it comes to NFTs, idea is like, let's say there is some commodity, there is some object, or there is some entity, and you want to convert it into digital identity, and then you want to trade around it. So yes, NFTs is another very important application of blockchains, where you can transform or map your physical assets or entities into digital tokens, and then you can use it for ownership, right? To define the ownership of that particular entity. And you can have trade around that also. So there are many different kind of applications. Then you have digital, what do you say, distributed finance also, where you can have this loan facilities among various stakeholders. And it could be peer-to-peer direct, like if somebody wants to take loan from some other person, so without anybody in between and paying for commission, high commissions and other things, and high interest rates, you can have direct finance based services. And you will see more such applications coming up in the coming days, where dependency on intermediators and other players will become less, and it would facilitate the stakeholders, the participants, because this would reduce the overall cost of processing and the cost of the facility also, services. So these are the things, right? Now, this is very important slide. Basically, it's a framework by Niti Aayog, right? And basically, the idea is to give a clarity on when to use blockchain and when not, right? I told you earlier also that it's not that if you have a blockchain based technology which gives you security and immutability, that we should use it everywhere. It totally depends on what value addition blockchain can bring in, right? And yes, total cost of ownership is also a matter of concern, right? So we need to evaluate, we need to assess whether blockchain is suitable for us or not. So if you look at this diagram, this is a framework on blockchain use case selection. It means this framework can guide us whether we should use blockchain or not. You might be feeling that this diagram is quite complicated, but let me tell you, it's not at all complicated. There's a trick of understanding this diagram. The trick is that the whole diagram has got blue boxes and yellow boxes. Blue boxes are the decision boxes. Decision boxes means some parameter decisions that we have to take, evaluate. And yellow boxes are the outcomes, right? Means whether we have to use blockchain or we do not have to use blockchain. If we have to use blockchain, whether we have to use a public blockchain or a private blockchain. And finally, whether we need a customized solution where you need to make some more changes and research in how your business objective would be met through blockchain, right? So before we start with this diagram, I want to quickly give you some inputs on what should be our approach as a chartered accountant towards blockchain based applications, like whether we should use blockchain or not. That's basically a key question that everybody should be worried about, right? And that's I think the most important takeaway from this session is when to use blockchain, right? So the question is when to use blockchain, right? So I would like to give you some inputs, critical inputs. If there are multiple intermediaries, then I think it's a strong use case, right? You need multiple people verify complete transaction, right? Let's say that you have a process where there are multiple intermediaries and multiple people who play a critical role in verifying the transaction. So if you have this kind of scenario, I think that is more suitable for blockchain. Reason being, because there is a cost of ownership. I told you there will be n number of machines which will have same kind of software running, and then when you're doing operation, machines would be verifying the transaction, and then the transaction would be verified and would be stored in the block, right? So if there are multiple people involved in this whole process, it's a more suitable case. Why? I'll quickly give you a scenario here. Let's take a use case so that you get it more effectively. Let's say there's a use case wherein say loan application. For property. Right? Loan application for property registration. Okay. Let's say this is a thing. Now, first of all, you need an applicant. Right? And you know that when you apply for a loan, the loan is sanctioned and the check is basically presented when you are going for property registration, and the check is given to the seller, and the property documents after the registry is taken up by the bank. Okay. Now, the point is that it's a very lengthy process and there are so many people involved. Applicant, then legal player for evaluation and verification of property and various other things. Right? Then you have bank, right? Then you have a registrar who will register the property. So you can see there are different players involved in this. And the process goes like this. The applicant basically applies, right? Now, when you are applying, you will enter certain data like your name, this into an application. So how this blockchain application will work? So there is an applicant. He will log into a blockchain application. Loan-based blockchain application, right? So LBA, let's give it a name. LBA application name is LBA. So applicant applies, sends some details to this application LBA. Now this is a blockchain application, right? So I told you earlier that the idea behind blockchain is to build the trust within the technology. So this LBA application has got various components, right? What are those components? First, distributed ledger. As we all know that there is a network of machines. There will be various machines on top of which this application is working. Basically, application is just a front end. In the back end, what is there? There's a distributed ledger, right? Let's say 40 machines are there. Okay, 40 machines are there. Then there is smart contract, right? Now, what is smart contract? Smart contract is again a program, a software which basically maintains rules and conditions for processing, right? You must meet all these rules and conditions, only then your transaction would be approved or completed. Otherwise, it would be rejected, right? So, and then beside this, there is API connectivity with other applications. Okay. Now what happens? So what happens is in this whole the application, what happens is applicant comes to this application and applies for loan. This is how this loan application or blockchain application will happen, right? So applicant has logged in, created a profile, applied for a loan, right? He will select the bank. This application is there. Now this application has got various things in the back end. API connectivity with other applications and banks. Right, it has links with other applications like your PAN based applications, Aadhaar. All these applications are connected to our LBA through API connectivity. So it means that there will be no human intervention. Direct human intervention would not be there. So applicant will enter the details in this application, right? It will go into the distributed ledger and all these things, like the moment he enters his PAN number, a button would be there for PAN verification. The moment PAN verification is done, then next step is you have to go for Aadhaar verification. Aadhaar verification is done. The next thing is you will select the bank and the other thing like the loan amount, and then you will select the property. The moment you will select property, your application will basically again get a communication with registrar system, property registry system, right? So it means that blockchain application is an application which is connected to all other applications which are part of the whole process. So means there'll be right. So the moment you apply, a legal player would be associated with the application, and the person would be asked to evaluate the property and other things. And basically this activity or process would be automated, because we don't want any manual intervention. What will happen is automatically the property that you have selected, property registry system will give you the valuation and everything, the circle rate and everything about that application, and it would be computed automatically and would be reflected on the thing. and then it will ask you for your salary details and everything, so that the loan amount can be evaluated. Then there will be interconnectivity with CIBIL score and other agencies also, right, to get that data also. So it means there will be no human intervention, and all these activities would be processed, and after this successful processing and verification, your application would be verified and completed, and you will get an approval acknowledgement right, about that your loan is approved, and with the date, like when onwards, or you can say when you want to apply for a registration or something like that. And perhaps if you have that level of automation, you can do one thing, that this loan approval would be there, and your property would be registered automatically, and you will get the certificate of the transaction, and the property documents would be stored in the custody of, what do you call that, bank who is offering the loan, right? That process would be like your physical documents would be sealed and packed and would be sent to the bank, right? That needs to be decided, but otherwise these things, these activities can be done automatically with the automation and connectivity of your blockchain application, right? So this is I think the only thing here is that the physical documents which are there for against your property, registration of your property, that needs to be sent to the bank. That needs to be defined on how it will happen, and maybe there will be a time given to you, or you can do this way, loan approved, and then you may be given a time slot, that there's a time slot for your appointment, physical appointment, where the bank employee will share, or bank executive will share the check, and then you can, and the executive can take the this property documents. So this is one use case. Similarly, there can be many use cases. So the idea behind the blockchain is there's an application, or you can say a wallet, right? And what happens is, this wallet is basically an application through which you can initiate a transaction, right? Initiate a transaction. Okay. Once this transaction is there, this goes into a distributed ledger. Basically, network of machines. Out of these machines, one machine is selected to verify and validate the transaction. So this is the transaction that you have sent, and distributed ledger is there. One machine would be selected for verification of and validation of the transaction, and then it will also incorporate smart contract. It will talk to the smart contract and will pick up all other business rules also, which are to be considered for verification and validation. Once all these verification validations are done, the machine confirms, acknowledges successful or acknowledges validation, and the transaction is added to the block. And once the block is mined, it is added to the chain. And once it is added to the chain, the transaction gets completed. So this is how this whole process happens. So the user will get an acknowledgement that transaction is complete. Right? So this is how this happened, right? Now, the point is, if we look at this, okay, this is an application, so it must have some controls like login and all other authentication things. Distributed ledger is a network of machines, highly secure. You cannot really mess with this. And the strength depends on the number of nodes. More the value of n, more stronger it is. But then there is a trade-off. It may be a little slower also. As the n increases, performance goes down. But as the n increases, security also increases. So you need to define that level of n, that number, which gives you your what do you say, required performance, required trade-off, right? Means how much is that optimal or acceptable level. So this is the other area for concern. Like one is the controls at the application. Second is the number of nodes, because we need to define the performance and security. The third parameter is the smart contract. What are the rules for verification and validation? They should cover all the rules. There should be no mismatch or what do you say, flaw in this, right? So these are the three areas where auditors should be careful, like the application controls, number of nodes, because that directly defines the security level. And then whether the smart contract incorporates all the business rules, all the computational rules which are required for successful transaction, right? So these are the things that you need to check as an auditor, right? And the total cost of ownership is very important. And you should make sure that you are designing an application which involves multiple intermediaries, right? Otherwise, it would not be cost effective. The ownership will be very expensive. Now, I think we are good to go with this diagram, and I'll quickly explain you what this framework tells us about how we should select blockchain for a particular business case or a problem. So you can see this, these blue boxes are the decision points, yellow boxes are our potential outcomes, and then you have arrows which will give you navigation. So this is the start pointer. Start. First, is there a compelling business case to reduce intermediaries? Do you really think that the intermediaries are leading to serious cost and you want to eliminate those intermediaries? If yes, then there is a possibility of blockchain. But if it says no, then you should not go for blockchain. Okay. So considering the case like academics, property registration, credit card application, loan verification, loan application, all these are important cases where we want to reduce intermediaries. That's why, so we have to go to step number 2. Are multiple stakeholders involved? Like, who are the parties? If there are only 2 parties, then there is not good. If there are multiple parties involved, then it is more useful, because we'll be having more, what do you say, orchestration, optimization. Idea behind blockchain is to eliminate human intervention and make it digital system where technology will take care of the processing, verification, and trust automatically. It will reduce the time taken in completing that process manually, and of course it will incorporate security also. So if multiple stakeholders are involved, then we can move to the next step. Otherwise, go back. Are you working with digital assets instead of physical assets? If it is digital assets, directly go to the next step. But if it is physical assets, we need to check whether those physical assets can be converted into tokens or not. Here comes the concept of NFTs, right? So we can map these physical entities or things into tokens, NFTs, and those NFTs can be mapping of that physical asset and can be used to represent ownership, right? Which can be transferred based on the use case. Anybody wants to claim that ownership can claim based on the, again, the process and the protocol and the rules. Like if you want to have a painting and then you want to have a trade around that painting, you can convert that painting into an NFT, and then accordingly, whosoever has the possession of that NFT is the actual owner of the painting, right? So that way things can be done, right? And it can really reduce a lot of problems. So there are interesting use cases. If you start exploring where you can apply this blockchain and NFTs, you'll see some interesting use cases, right? So the idea is, if you can map your physical products or entities into tokens, then it is good for blockchain based implementation. Otherwise it is not. You can go back. Can you couple digital asset and physical asset with permanent and authentative record of proof? Means when you are mapping your physical asset with your token, you must have a mechanism that there should be no tampering, right? Let's say, for example, you create a painting, or let's say there's a shoe, right? And say there's a big brand and they have a very expensive shoe. They have manufactured a shoe. Now you want to convert this physical asset, shoe or a painting, into a token or an NFT, right? You converted it, right? There's a number or a token. But now this physical asset, your painting or your shoe, is not properly packed. It can still be opened and can be tampered. Then it's not good use case for blockchain. So blockchain needs one more, assurance that physical asset which you have mapped with the NFT or a token should have adequate security and authentication mechanism, that no physical tampering should be done on that particular asset, right? If that is ensured, then it's good to go with this tokenomics based concept, like physical entities have been converted into tokens, and then now you can put it on blockchain based network, right? So once you have addressed this issue with the digital asset, there is no problem, but with physical assets you need to maintain this record of proof and authentative record of proof. Like if you recall, I was discussing this case, property registration, the physical papers, right? That needs to be mapped with token, okay, fine, but this physical papers need to be handed over to the bank executive in a safe manner, and then bank executive should keep it in a very safe manner. If that cannot be ensured, then blockchain is not successful, right? So this is what this means, like physical asset mapping with the token needs to be authentic and with a proof of record, right? And it should be tamper proof. So once this is decided, this asset type and nature and mapping in digital format, so next question is, do multiple parties require shared right access? Means they need to make some addition or right in the transaction. For example, token may change hand many times, which means that the physical asset will also change hands, or it will be with some repository and token is used just to trade. I think yes, interesting question. And yes, like if your token is changing hand, so definitely yes, the physical asset will needs to be of course handed over to the actual owner of the token, right? Token is just a proof of ownership, right? And if it is a physical entity, of course, it should be in the custody of the actual owner only, right? Let's say if somebody steals, let me give you the clarity about why NFT is important. Let's say somebody steals it, right? Now you file a complaint and inquiry is done, and the same material, the product is found with a person who's basically a thief or somebody. Or maybe let's say he's an expert, he's a hacker or a legal expert, and he has all the information and everything, right? Now he has to prove his ownership, right? If he is failing in proving his ownership, then it's clear and evident that he's a thief. Now if you have the token and it is registered with your private key and everything, it means you are the actual owner. So token basically gives you assurance on ownership, right? So a physical asset will also change hand, and in any case, if somebody steals that physical asset, you can claim the ownership based on the NFT, the token you have, right? So in a way, you are basically creating a security mechanism which makes you the actual owner of something. Even if somebody steals it, you can prove that you are the actual owner, right? I hope I have addressed the question, Neeraj. Okay, but let's say I don't want physical. Okay, if you don't want physical ownership, then again, then it is a different situation altogether. It means it's a different use case. For example, let me tell you one thing. Let's say there is some property. There is some property, and you want to have its ownership, but you don't want to have physical ownership. You have just purchased it for the sake of investment. Let's say that. So it's fine. You keep your token with you, and the day you want to sell it, you can sell it. Whosoever will have the token will be having the ownership of that thing as well. Now that's a totally different use case, right? When I was telling you about that, what do you call the shoe thing? The shoe thing is totally different, right? Because let's say you want to go and purchase a shoe, a branded shoe, let's say Reebok or some other shoe, right? Now the thing is, you want to ensure that it's an original product, right? You don't want to pay or spend your money for a fake product, right? So through an NFT, you can actually address this situation. You can actually check and verify whether the product is genuine or not, and then when and where it was manufactured, whether it is a genuine product or not, what was the life cycle of that product till it reaches to you, till you purchase it. So all those things can be achieved with the help of NFTs also. So having said that, I must tell you that NFTs and these blockchain can be used in many ways, right? And it totally depends on the situation, business case, or the problem, use case. And it is customizable. I told you it's customizable. The way you want it, you can design and implement accordingly. Yeah, right. Thank you. So moving on, the next question is, do multiple parties require shared right access? For example, when we are applying for a loan application, first of all, our identity is verified. So who will verify my identity? Like PAN, there's an agency for that. For Aadhaar, there is another agency. For evaluation, registrar is there, whether I'm claiming or applying a loan for a genuine property or not. So that needs approval or verification from some other party. Means, so there are multiple people, parties involved who will be contributing to the transaction. If there are multiple parties involved, then again, it's a very strong case for blockchain, because our blockchain application will eliminate manual intervention, and all these rights, like multiple parties are involved in completing the transaction, will happen digitally. So it means it's a very interesting use case, very genuine use case for the blockchain. Then the next question is, do you require high performance? If yes, it means you need to customize your blockchain application. Otherwise, if it is not a mandatory requirement, like you need a very high performance, then you can move on to the next question. Do you intend to store non-transactional data as part of your solution? Means, do you want to store non-transactional data, like non-master data, also in the blockchain? If yes, then again, your blockchain needs to be customized. During the demo, I told you, it's totally dependent on your requirement, whether you want to keep the data in the blockchain or you just want to have its hash code, right? So based on that, based on your requirement, you may have to go for customization, right? Directly, blockchain doesn't address this, but yes, you can customize the blockchain according to your requirement to incorporate your functionality, right? But if you don't want to store non-transactional data, you only want to have transactional data, so you can directly move on and you can go to the next question. Do you need to rely on trusted party for compliance reasons? If there are compliance requirement and you need some control check or verification validation based on some other parties also, then again you need to customize the solution, because those compliances need to be incorporated, and that requires agreement from that particular party also. If that party agrees, then it's fine. If that party doesn't agree, then the blockchain is not feasible, right? So that needs to be addressed and customized. But if there is no requirement of any such compliance, then you can move on to the next question, that is, do you need the ability to control functionality? If you want the ability to control functionality, it means you are looking for a private blockchain. It's a strong case for private blockchain where there is an ownership. Having said that, of course, there is an ownership. You are the owner of the blockchain, but still it is a transparent distributed ledger. All the player in the blockchain will have equal accessibility, capability, and transparency. You on the blockchain doesn't mean that you can tamper the blockchain, right? So please have a clarity around that. So there are two concepts: public blockchain, private blockchain. Private blockchain can be owned by a party, agency, or an organization, but that doesn't mean that they have the ability to alter the data, right? They are just like one machine in the whole blockchain, right? So that way these blockchain systems are designed that nobody, even the owner, cannot tamper the data. So do you need ability to control functionality? No. Then you go to the next question: should the transactions be public? If the transaction needs to be public, then it's a strong case for public blockchain. But if you don't want to keep transaction public, then it becomes strong case for private blockchain. For example, let's say you want to have an application for your operations, like your in-house operations, transactions with the vendors, transaction with your clients, right? And they are, what do you say, within the domain, right? And then you have defined who are acceptable, who are not, right? So you have control on who are your potential clients, vendors, suppliers, and only these are the participants, not everybody, right? There is no public what do you say, access and public accessibility to your blockchain. Then it's a strong case for private blockchain. But if it is for a public use or public service, then it's a strong case for public blockchain. Like you have these you can have various applications, let's say e-voting, right? E-voting is there, but in that case you can define that only the resident of a particular country or a citizen of a country are allowed to have participation in e-voting, provided they have valid what do you say, ID or voter ID. This is one such case. Then you can have property registration, right? A public blockchain means a private blockchain for open public access. I think this can be used by jailers for authentication. Oh yes, let me tell you, this diamond industry was one of the what do you say, major industry to adopt blockchain after finance industry, right? So interesting observation, and very rightly observed by Neeraj sir. Yes, diamond industry is one of the big adopters. They were quick adopters of blockchain in their trade. So yes, diamonds, authentication of diamond, and the journey of the diamond can be recorded on blockchain so that you can have proof of authenticity, right? Same way, in the future, you will see that organic farming and agriculture products would be again mapped to blockchain so that you can have actual clarity of the originality and authenticity of the product, so the food that you are purchasing. So there are interesting use cases, and let me tell you, there are so much of research going on, so much of what do you say proof of concept based projects are happening in blockchain, that you will see a lot of more projects coming up in the near future. So this is a framework by Niti Aayog, and it gives you a clarity about how you should decide on whether it's good to go for blockchain or not, right? But I must say, you must have clarity about public blockchain and private blockchain. Private blockchain can be owned by an entity for their operations, right? And they can still enjoy all these features, immutability, transparency, and everything. And public blockchain is a blockchain which is not controlled by anybody. Anybody can participate, and nobody controls, nobody regulates it, right? Like your Bitcoin or any other cryptocurrencies, right? So these are basically examples of public blockchains. Now, impacts on audit. Let me quickly give you a clarity about that aspect of blockchain also. Well, you know now what is blockchain, and if a blockchain-based system is there, The only thing you have to focus about is the application controls and smart contract and the rules, because everything is getting converted into hash and there is no loss of integrity, data integrity, no tampering can be done. So there is no need of verifying the transactions, right? So your audit objectives will change. Let's say there's a blockchain based application, right? Let's say accounting application on blockchain or any other finance application. If you're auditor of that application, you don't have to go for substantive testing, checking all the records and then fetching all the transaction data, and you're applying your tools of data analytics and all, like Excel, ACL, idea, all those things, and then you are verifying, okay, all transactions are complete or fine or not. You are doing reconciliation and all those things are not required if you are having a blockchain based system, because there can't be any tampering of data or manipulation of data or change in the data. The only thing you have to focus on is whether you have proper controls on the application, authentication controls and other cryptographic controls, and the smart contract where the rules are there. All rules are incorporated, all business rules are incorporated, and all are being followed during every transaction. So you need to check that only. You don't have to actually go for a transaction verification, because that's already an automated process. So there will be no tampering, no human intervention is there. So as an auditor, your role changes. Now you have to focus on audit on smart contract. So you have to check and verify all the business rules, compliances that should be covered in the smart contract. And if it is a permissioned blockchain, you need to understand the design, number of nodes, and all those things. Proper application control should be there around the application through which the transactions are coming. So this is what your role is when you are having a blockchain based application. And the other interesting opportunity for you all is that you can be a consultant, an active contributor in deciding on how the application should be designed. As I told you, it's a customizable technology. The performance, what you want to store, the tokenomics, all these are the factors that needs to be decided from the inputs of an expert like chartered accountant or a person who has understanding of the process. Without those inputs, you cannot create or design a good blockchain. So your role would be a role of consultant, and you must make into consideration the compliances regulations which are required if you are moving to blockchain application. Like there could be compliances related to data privacy, continuity. So all those things should be covered in the application, right? Or you must have some provisions which address those requirements of the application. And you should make sure that whatever integrations you have with other parties and agencies, those should be through secure APIs, or cryptography should be used to ensure confidentiality and integrity. And yes, as I told you, you can be a consultant who can be part of the team who is evaluating the design, how the application should be designed, like what should be the flow of operations. Then proof of concept, like the prototype, the dummy prototype model would be designed first, it would be tested. You can play an active role in testing of that application. Then you can contribute in assessment of the risk, whatever risks are there. That risk assessment is a very critical activity that can be taken up by practitioners, chartered accountants, or people. And finally, audit of smart contract, the rules. And if it is a hybrid blockchain, means some data is in the blockchain, like chains, blocks, and some data which is non-transactional data which is there in the database. So you may have to check both the rules and the data in the database. So that way, it totally depends on the design of the blockchain, that how you will go about testing it or evaluating it. Finally, a use case. I can give you a very interesting example here quickly. Let's say we have a digital identity system on blockchain. Let's say government of India or any other government comes up with this blockchain based system of keeping digital identity of every individual. The moment a person takes birth till the person dies, all those things and key events are recorded in the blockchain. Like the moment you take birth, a birth certificate is generated and your digital identity is created. Okay. You apply for PAN card or a taxation, it is again recorded in the same entity, right? And then let's say you graduate, you get some degree or certificate education, all those things are again part of that digital identity. And then let's say you get passport, all these are transactions that are happening on the blockchain. Now you know that these informations are critical and personal identity information, and you need these information and verification at various stages of your life, right? So if you want to use it, all these different applications can directly connect to this application with a single API call and can get KYC done or verification done, right? So you can see how interesting and how useful this system would be, and how we can ensure more smooth and faster operation and minimization of frauds and tampering and duplicacy, right? So this is a very interesting application. I thought I must share this. If we can have this digital identity based system, our life would be a lot more easier, right? And a lot of research is happening, and sooner or later you'll see such kind of systems in operations, right? So be ready for a serious changes in the time to come, right? In next 10 years, 20 years are really going to be revolutionizing, considering the amount of technology we'll be observing around us, the different kind of applications driven by technologies around us, be it blockchain, be it data analytics, be it business intelligence. IoT is a big thing that is happening. So you'll see more and more such systems and applications around us, right? And land registry, I think I discussed during the discussion also. So this is again a very interesting use case because there are so many frauds around property registration. So this is again a interesting use case for blockchain application. So that's all from my side, and I hope I have given you a quick insight and perhaps the right, what do you say, initiation, or I have given you the right direction so that you have a clear perspective about blockchain. And now you are in a position to explore blockchain further, and you can take up this basic information, and now you can explore further and you can look for potential opportunities in the area of blockchain. Thank you all, and thank you Bengaluru branch of SIRC, and thank you all the panel members. It's been a great privilege and honor to be part of this panel where we have senior members like Rafiq sir. It's been a long association. Then we have many other, Narsiman sir and Jangir sir. I thoroughly enjoy, and thank you all the participants. I hope you got a clarity. Over to you, Narayan sir.
Thank you, Sir Vinay. I'm sure you have enlightened us with all the upcoming and the latest informations about the blockchain technologies and how we as a chartered accountants can utilize, and probably what should we be aware of when we get into the audits or other aspects pertaining to the blockchain technologies. So I'm sure it was very enlightening. And thank you so much for your session, sir. We are very much obliged and happy that you are part of today's session.
Thank you, Narayan sir. Thank you.
Thank you so much, sir. And thank you, Abdul Rafiq sir. Thank you so much. And thank you all participants for the active participation for the one-day seminar. Thank you all on behalf of ICI Bangalore, and thank you chairman and the rest of the committee members as well. Thank you so much. Thank you all.
Thank you.
Thank you, sir.